Hey everybody, welcome back to our second video. This second video is just going to walk through some of the extra practice examples that we had in this lesson. Now for 9 and 10, assuming you did what I asked and started looking at these first, notice that 9 and 10, neither one had y equals. Both of these were in that weird or standard type form. So both of these, because it's not y equals, both of these are going to need the x-intercept and y-intercept in order to plot my graph. So for my x-intercept, that's when I set y equals 0, and I find an x value to go with it. So I leave x alone. X equals 3y, so 3 times 0 minus 6. But 3 times 0 is 0, and 0 minus 6 is negative 6. So that creates an ordered pair, negative 6 for x, 0 for y, a single point on the graph. For my y-intercept, I set x equals 0, and I find what y equals. So if I plug in for x, I end up with 0 equals 3y minus 6. In order to get y alone, I undo by adding 6 to the other side. And I undo 3 by dividing 3 to the other side. 6 divided by 3 is 2, and y is now alone. So together, the 0 and 2 create another ordered pair. 0 side to side, 2 up, and I get to graph my line. Because number 10 was also in that weird form, y was not alone, I had to go the x, y intercept route. Whoops, just wrote that backwards. So to find my x-intercept, I'm going to set y equals 0 and find x. So leave 4x alone plus 2 times 0 equals 8. But 2 times 0 is just 0, which really means I have 4x equals 8. And when I divide both sides by 4, x equals 2. Careful of your order here, because in my ordered pairs, the 2 comes first, then the 0. 2 on the x-axis, x-intercept. For my y-intercept, it's the y value I'm trying to calculate. So wherever the x is, this time I plug in the 0. But just like before, 4 times 0 is just 0, and 0 plus 2y is just 2y. Then to get y by itself, I divide 2 to the other side, and I get y to be 4. Giving me a second ordered pair, 0 for x, 4 for y. 0 side to side, 4 up on the y-axis. Keep in mind, if it's an x-intercept, it should sit on the x-axis. If it's a y-intercept, it should sit on the y-axis. Number 11. Now, number 11 shifted gears on us a little bit because now y is alone. And when y is by itself, we are in the form y equals mx plus b. Whatever number is in front of my x, so in this case the negative 2/5, is what I use for my slope. And whatever number is by itself is what I read off as my y-intercept. Meaning 0 is going to be the x, and I use 3 on the y-axis. 3 on the y-axis, y-intercept, is what I start off with, plotting for my starting point. Then I use my slope to move to the next line. A -2 tells me I should go down. +5 takes me to the right. Down 2, right 5, giving me that second point. Number 12. Now notice, number 12 is a little weird because I don't have a y value. The y value, or the y variable I should say, is missing. This is one of those special cases that are either going to run up and down or side to side. But I don't know where until I get x alone. So subtract 3 to the other side, giving me x equals, and 2 minus 3 is -1. So in this special case, when I only have one variable, I plot this as if it's the x-intercept. So I find -1 on the x-axis, and then I cut the x-axis. Don't go with it, cut it, giving me a vertical line where my slope is undefined. Only 2 more. Looking at 13, I have x minus 3y equals -3. This is another one of those, once again, that's kind of weird. X's and y's together. This is standard form. Right? Y is not by itself. So I'm going to find my x and y intercepts. For my x-intercept, we make y equals 0. So I have x minus 3 times 0 equals -3. In doing that, -3 times 0 is 0, which really just disappears, right? X minus 0 is just x, and x is -3. So together, those create the ordered pair. Put the x value first, y value second, meaning I should plot a point on the x-axis at -3. For my y-intercept, I go the other direction. X equals 0. Find a y. So 0 minus 3y equals -3. But 0 minus 3 does nothing for me. I have -3y equals -3. And divide -3 to the other side. -3 divided by -3 is a +1, which creates a second point. This time, a y-intercept, a y value of 1. Now in number 14, if you tried number 14, you might have noticed it gave you some weird kind of fractions. As an x-intercept, it would have given you 4/5, 0. And as a y-intercept, it would have given you -4. Just plugging in x and y. So -4 on the y-axis. 4/5 is almost to the number 1 on the x-axis. But I mentioned in our first video, and I never actually showed you an example, that one of the options in standard form would be to solve for y. Force it into y equals so that I can use y equals mx plus b. This would have been one of the perfect examples or perfect opportunities to do that, because if I want to get y by itself, I can simply add 5x to the other side, giving me y equals 5x and a minus 4. Technically, you could do this for any standard form. But notice that it's not always quick and easy. If I try to do that for 13, I would have had to deal with the x, I would have had to deal with negative 3, and it probably would have gotten weird. But if y already looks to mostly be by itself, this could be an option for you. It will give you the same line. It would have given me a slope of 5 that I would have needed to put over 1 in order to have a rise and a run. It would have given me a y-intercept of negative 4, which we had already plotted. So if I had gone this route, from my negative 4, I would have gone up 5, right 1. Notice those are all still in line. So I just wanted to take a chance to show you that other option. Although I warn you, it is not always the easiest option to try and transform from standard into slope intercept. Hopefully you have found this as good practice. If you have questions or concerns on these, when to use what method, reach out, take it to tutoring. Only if y is by itself can I straight just read off slope and y-intercept. Any other time, x and y-intercepts might be your best bet. But with that, friends, that wraps up this semester. If you have any questions or concerns, make sure you reach out. Bye, everybody.